Technology has always evolved to make our lives easier, but sometimes it evolves in ways that challenge our very sense of privacy and control. Imagine particles so small they float in the air, invisible to the naked eye, yet powerful enough to sense, record, and transmit information. This isn't science fiction. It's smart dust, a breakthrough in nanotechnology that could redefine surveillance forever. In this first part, we'll explore the origins of nanotech, the early experiments that made smart dust possible, and the chilling implications of a world where the air itself can watch you. Nanotechnology began as a dream in the mid-20th century, when scientists imagined manipulating matter at the atomic level. Richard Feynman's famous lecture, "There's plenty of room at the bottom," inspired generations to think small, literally. By the 1980s, scanning tunneling microscopes allowed researchers to move individual atoms, proving that nanotech wasn't just theory. This was the foundation for smart dust, the idea that microscopic machines could one day perform tasks too small for human hands. The U.S. Defense Advanced Research Projects Agency, DARPA, quickly saw potential. If nanotech could create sensors smaller than grains of sand, they could be scattered across battlefields, cities, or even inside buildings. These sensors could detect movement, sound, temperature, and chemical changes. Early prototypes were crude, but the vision was clear. Invisible surveillance networks that required no wires, no cameras, and no human operators. Smart dust was born from this military ambition. In the 1990s and early 2000s, researchers developed motes, tiny sensor nodes with limited computing power. They were larger than dust, but they proved the concept. Each mote could sense its environment, communicate wirelessly, and operate on minimal power. As technology advanced, motes shrank, processors became more efficient, and wireless communication improved. The dream of scattering thousands of sensors into the air became increasingly realistic. Smart dust relies on microelectromechanical systems, MEMS. These are tiny machines etched into silicon, capable of sensing vibration, light, or chemicals. Each particle contains a sensor, a processor, and a transmitter. Together, they form a swarm, a network that shares data in real time. Imagine thousands of invisible particles floating in a room, silently recording everything. This is the science that makes smart dust possible. The implications are staggering. Unlike cameras or microphones, smart dust doesn't need to be installed. It can be sprayed, scattered, or even inhaled. It can monitor environments continuously without detection. For militaries, it means total battlefield awareness. For governments, it means unprecedented surveillance. For corporations, it means tracking consumer behavior at microscopic levels. Smart dust matters because it represents a new frontier of control. Beyond surveillance, smart dust has potential in healthcare and science. Imagine particles inside your bloodstream, monitoring vital signs and transmitting data to doctors. Imagine sensors scattered in forests, tracking climate change in real time. Imagine logistics systems where every package carries invisible dust that reports its location. Civilian applications show that smart dust isn't just about spying, it can revolutionize medicine, environment, and industry. But with great power comes great risk. Who controls the dust? Who decides where it's deployed? If smart dust can monitor health, it can also monitor behavior. If it can track packages, it can also track people. Ethical concerns about privacy, consent, and misuse dominate discussions. Once deployed, smart dust is nearly impossible to remove. The question isn't just what it can do, it's what it should do. Picture a future where classrooms are filled with invisible sensors tracking student attention. Picture workplaces where every movement is monitored by dust in the air. Picture cities where smart dust forms a permanent surveillance grid. These scenarios may sound dystopian, but they are technically possible. The line between science fiction and reality is blurring. Smart dust began as a dream of nanotech pioneers, but it has evolved into a tool of surveillance and control. Its origins reveal both the brilliance of human innovation and the dangers of unchecked ambition. But this is only the beginning. In the next part, we'll explore how smart dust actually works, the mechanics, the swarm intelligence, and the chilling ways it can be deployed. Stay tuned for video 2, where we dive deeper into the mechanics of smart dust and uncover how invisible particles can form networks that monitor entire environments. The story of smart dust is far from over, and what comes next may shock you. Ever wondered if the dust motes dancing in a sunbeam could actually be watching you? It sounds like something straight out of a sci-fi movie, but this technology isn't just a fantasy. It's called smart dust, and it's poised to revolutionize everything from military intelligence to environmental monitoring. So, what exactly is smart dust? Imagine tiny, almost invisible sensors, no bigger than a grain of sand. Each one is a complete, autonomous system called a MEMS, which stands for Micro-Electromechanical System. These aren't just simple specs. They're packed with sensors, a power source, and a way to communicate. They can detect light, temperature, vibrations, chemicals, and so much more. Think of them as microscopic spies scattered across an area, gathering data and reporting back. How do they work together? It's all about networking. When you deploy thousands or even millions of these motes, they form a wireless sensor network, passing information along like a relay race until it reaches a central computer or a larger base station. This creates a massive invisible web of information, giving you a real-time, high-resolution picture of an entire environment. They can be dropped from planes, mixed into paint, or even woven into fabric. The possibilities are mind-boggling. Powering these tiny devices is one of the biggest challenges. Batteries are too big and run out of juice. So engineers are getting creative. Many smart dust motes are designed to harvest energy from their surroundings. They use tiny solar cells to soak up light, or they capture energy from vibrations, temperature changes, or even radio waves floating in the air. This allows them to operate for years without ever needing a battery change. Now, let's talk about the game changer, the military applications. This is where smart dust goes from a cool concept to a powerful strategic tool. Imagine scattering these motes over enemy territory. Suddenly, you have eyes and ears everywhere. You can track troop movements, identify vehicles by their vibrations, and even detect the chemical signatures of explosives or biological agents. It's like having an invisible, all-seeing surveillance network that the enemy doesn't even know exists. This completely changes the rules of reconnaissance. Instead of risking pilots or satellites, you can get detailed ground-level intelligence safely and discreetly. You could monitor supply lines, detect ambush before they happen, and assess battle damage with incredible precision. The motes could be painted onto enemy vehicles to track them, or scattered around a suspected weapons facility to confirm its activities. It provides a level of situational awareness that was previously unimaginable. Furthermore, smart dust can be used for perimeter defense. Sprinkle them around a military base, and they can detect any unauthorized movement, day or night, in any weather condition. They can differentiate between an animal, a person, and a vehicle, reducing false alarms and giving soldiers an early warning of any potential threats. This invisible fence is far more effective and harder to bypass than traditional security measures. But the applications don't stop at surveillance. Smart dust can also be used for logistics. Imagine embedding these motes in the military equipment and supplies. You know the exact location and condition of every single item, from a box of ammunition to a jet engine part. This would streamline supply chains, prevent losses, and ensure that critical resources are exactly where they need to be, when they need to be there. It's a logistical dream come true. Of course, with great power comes great responsibility and some serious ethical questions. What about privacy? If this technology becomes widespread, could it be used for mass surveillance on civilian populations? The idea of a government being able to monitor everything, everywhere, is a chilling thought. We need to have serious conversations about regulations and safeguards to prevent misuse. And what about the potential for a new kind of warfare? Imagine an adversary deploying smart dust that can not only watch, but also act. Motes that could disrupt communications, disable electronics, or even deliver microscopic payloads. This is the darker side of the technology, and it's something military strategists are already thinking about. The race is on not just to develop this technology, but also to create countermeasures against it. Despite these concerns, the potential for good is immense. Beyond the military, think about the civilian uses. Farmers could use smart dust to monitor soil moisture and nutrient levels across vast fields, optimizing water use and increasing crop yields. Firefighters could deploy it in a wildfire to track its spread and identify hotspots in real time, saving lives and property. In medicine, doctors are exploring nano-sized motes that could travel through your bloodstream, detecting diseases at the earliest stages or delivering drugs directly to cancer cells, warning us of potential collapses before they happen. Environmental scientists could use it to track pollution, monitor air and water quality, and study delicate ecosystems without disturbing them. The technology promises a world that is safer, more efficient, and more connected to the data that surrounds us every day. So, smart dust is not just a futuristic concept. It's a real technology that is rapidly developing. From providing unmatched military advantage on the battlefield to revolutionizing agriculture and healthcare, these tiny specks of silicon are set to have a massive impact on our world. The next time you see dust floating in the air, you might just wonder, what is it seeing? Thanks for watching. If you found this fascinating, make sure to hit that like button and subscribe for more deep dives into the technology that's shaping our future. Let me know in the comments what you think about the future of smart dust. See you in the next one. We've seen how smart dust can transform the battlefield, giving militaries unprecedented surveillance power. But what happens when this invisible technology enters civilian life? In this part, we'll explore how smart dust could revolutionize medicine, environment, and industry, and why its potential raises some of the most urgent ethical debates of our time. Imagine particles inside your bloodstream, monitoring vital signs in real time. Doctors could track heart rate, oxygen levels, and chemical imbalances without invasive procedures. Smart dust could revolutionize diagnostics, catching diseases before symptoms appear. It could even guide drug delivery, releasing medication exactly where it's needed. Healthcare applications show the promise of smart dust as a life-saving tool. Smart dust could be scattered across forests, oceans, and cities to monitor climate change. Sensors could track pollution levels, detect toxic chemicals, and measure temperature shifts. Imagine a global network of invisible particles providing real-time data on the planet's health. Environmental scientists see smart dust as a way to understand ecosystems at a microscopic level. Factories could use smart dust to monitor machinery, detect faults, and improve efficiency. Logistics companies could track packages with invisible sensors, ensuring they arrive safely. Farmers could deploy smart dust to monitor soil conditions, water levels, and crop health. Industry applications show how smart dust could optimize production and reduce waste. Picture classrooms where smart dust tracks student attention. Picture offices where every movement is monitored for productivity. Picture homes where smart dust controls appliances, monitors health, and reports activity. Everyday life could become a network of invisible sensors, constantly recording and transmitting data. But with great power comes great risk. Smart dust raises urgent questions about privacy. If particles can monitor health, they can also monitor behavior. If they can track packages, they can also track people. Who controls the data? Who decides where smart dust is deployed? Privacy concerns dominate discussions about civilian use. Smart dust is nearly impossible to detect or remove once deployed. This raises questions about consent. Can individuals choose not to be monitored? Can communities refuse deployment? Without clear rules, smart dust could be used without permission, creating invisible surveillance grids that people cannot escape. Corporations could use smart dust to track consumer behavior at microscopic levels. Governments could use it to monitor citizens continuously. Hackers could hijack networks of smart dust to steal data or disrupt systems. Misuse and abuse are not hypothetical. They are real risks that come with invisible technology. Lawmakers struggle to keep up with technology. Smart dust challenges existing privacy laws, surveillance regulations, and ethical frameworks. Should it be banned in civilian areas? Should it be regulated like weapons? Should individuals have the right to detect and remove smart dust? These questions remain unanswered. Civilian uses show the promise of smart dust, but ethical debates reveal the dangers. It could save lives, protect the environment, and optimize industry, but it could also destroy privacy, consent, and freedom. In the next video, we'll explore speculative scenarios and global implications, asking, what happens when smart dust becomes part of everyday reality? Stay tuned for video 4, where we uncover speculative scenarios and the global impact of smart dust, from cities filled with invisible surveillance grids to homes monitored without consent. The future may be closer than we think. We've already seen how smart dust could transform healthcare, industry, and the environment while raising urgent ethical debates. But what happens when this technology is unleashed without limits? In this final part, we'll explore speculative scenarios, global implications, and the chilling vision of a world where smart dust becomes part of everyday reality. This is not just a glimpse into tomorrow. It is a warning about what may already be unfolding today. Imagine walking through a city where every breath you take, every step you make, is silently recorded by invisible particles floating in the air. These particles form a permanent surveillance grid, covering streets, buildings, and parks. Traffic is monitored in real time. Conversations are captured without microphones. And movements are tracked without cameras. Governments promote these smart cities as efficient, safe, and modern. But beneath the promise lies a darker reality, a digital prison where privacy no longer exists. Citizens live under constant observation, never knowing when or how their data is being used. The city itself becomes alive with invisible eyes, watching without pause. Now picture the workplace of the future. Offices deploy smart dust to monitor productivity. Every keystroke, every whispered conversation, every pause for thought is recorded. Employers claim this improves efficiency, ensuring workers stay focused. But employees feel the weight of invisible scrutiny pressing down on them. The line between professional oversight and invasive surveillance disappears. Imagine a meeting where even your body language is analyzed by particles in the air. Imagine a break room where casual conversations are logged and reviewed. The workplace becomes not a place of collaboration, but a cage of constant monitoring. In classrooms, smart dust could track student attention, measure engagement, and report behavior. Teachers might use it to identify struggling students, tailoring lessons to individual needs. But students will grow up in environments where every thought and action is monitored. Childhood curiosity becomes data. Playful distractions become statistics. Education shifts from nurturing creativity to conditioning obedience under constant observation. Imagine a generation raised to believe that being watched is normal, that privacy is unnecessary, that freedom is optional. The classroom becomes not just a place of learning, but a training ground for surveillance culture. Smart dust could enter homes, monitoring health, controlling appliances, and reporting activity. Families might benefit from improved safety, sensors detecting fires, monitoring air quality, or alerting doctors to medical emergencies. But the same particles could record private conversations, track movements, and report behaviors to corporations or governments. Imagine a home where even intimate moments are logged by invisible sensors. Imagine a family dinner where laughter is analyzed for emotional tone. The home, once a sanctuary, becomes another node in the surveillance network. Privacy, once sacred, dissolves into data streams. Governments could deploy smart dust across entire nations. Borders, airports, and cities become invisible surveillance zones. International organizations might use it to monitor climate change, but authoritarian regimes could use it to control populations. Imagine a world where travel is tracked not by passports, but by particles in the air. Imagine protests where every chant, every movement, every heartbeat is recorded. Global surveillance networks raise questions not just about privacy, but about freedom itself. The balance of power shifts from citizens to states, from individuals to institutions, from freedom to control. If smart dust becomes widespread, resistance movements will emerge. Scientists may develop detectors to identify invisible particles. Activists may demand laws to regulate deployment. Citizens may seek ways to reclaim privacy, building clean zones free of surveillance. But resistance will be difficult. Smart dust is invisible, pervasive, and nearly impossible to remove. Detecting it requires advanced technology. Removing it requires massive effort. The struggle between surveillance and freedom will define the future, with battles fought not in streets, but in the air itself. Smart dust challenges existing laws. Should individuals have the right to detect and remove it? Should governments regulate its use like weapons? Should corporations be banned from deploying it without consent? Legal systems worldwide are unprepared for invisible surveillance. Ethical frameworks collapse under the weight of new questions. Is it ethical to monitor health if it also monitors behavior? Is it legal to deploy smart dust in public spaces without consent? These battles will shape the future of technology, determining whether smart dust becomes a tool of progress or oppression. The global impact of smart dust is profound. It could revolutionize medicine, protect the environment, and optimize industry. But it could also destroy privacy, empower authoritarian regimes, and create a world of constant surveillance. Imagine nations competing to deploy smart dust faster, creating invisible arms races. Imagine corporations using it to dominate markets, tracking consumers at microscopic levels. Imagine societies where freedom is redefined, not as the absence of control, but as the illusion of choice under constant observation. The implications are not just technological, they are cultural, political, and existential. Smart dust represents the ultimate paradox of technology, invisible, powerful, and unstoppable. It could save lives, but it could also control them. It could protect the planet, but it could also enslave its people. The future of smart dust is uncertain, and its implications will echo for generations. The question is not whether smart dust will shape the future, but how we will choose to live in a world where the air itself has eyes. This concludes our deep dive into smart dust surveillance. From its origins in nanotechnology to its military applications, civilian uses, ethical debates, and speculative futures, smart dust reveals both the brilliance and the danger of human innovation. Subscribe now for more global mysteries and tech reviews, and join us in Cycle 42, where we'll uncover the next wave of viral technologies and legends shaping our world.